turning CO2 into clean fuel faster and cheaper with the use of a catalyst. Every day, our planet releases billions of tons of carbon dioxide, and the amount of CO2 in our atmosphere has greatly increased in the past 100 years. Just like how CO2 is at the center of global warming, what if scientists could make it a part of the solution instead, by changing CO2 into clean and affordable fuel? A researcher from the University of Oslo says, to help reduce climate emissions in an economical, sustainable manner and facilitate the transition to clean energy sources, it is essential to recycle the CO2. For a while, scientists have been researching and trying to figure out a way to recycle the tons of excess CO2 in our atmosphere, but it has always been inefficient and expensive. But a recent breakthrough may have changed that outcome. The biggest challenge in converting CO2 into fuel is efficiency. The chemical reaction that is usually used to transform the carbon dioxide typically requires high temperatures up to 800 degrees Celsius, which is extremely hot, high energy, and expensive. Typically, nickel-based catalysts were used like this, but were not anywhere near as effective as we needed. On the other hand, if we were to use lower temperatures, previous catalysts became unstable and created unwanted byproducts like methane. So, the solution was to try and find a conversion method that works efficiently while also at lower temperatures to enable speed and cost effectiveness. A team of researchers from the Hydrogen Research Department, led by Dr. Ki-Young Koo, has newly engineered copper, magnesium, and iron mixed oxide catalyst. This catalyst is made from inexpensive materials and can also convert carbon dioxide at only 400 degrees Celsius, which is half of the usual temperature. Because this is a copper catalyst instead of the previously used nickel catalyst, there came problems with the copper's thermal stability weakening. Thermal stability meaning the ability of a material to resist breaking down under heat stress. The solution to this problem is in the structure of their design, a layer design made up of thin metal sheets with water molecules and anions between them. They keep the copper particles spread out instead of clumping together. This solution provides a more active surface area and keeps the catalyst stable, even under heat. Most importantly, this catalyst makes the reaction faster and cleaner. This new catalyst produces carbon monoxide, which is later used for making synthetic fuels such as electrofuels, and is at a rate at 1.7 times faster than any other traditional catalyst. This efficiency matters since CO, which is carbon monoxide, is the starting point of many fuels used in our economy. A cheaper, more stable catalyst means these fuels could become more affordable and easier to scale up. The new catalyst also remains stable for over 100 hours of continuous operation, displaying that it is strong enough for real-world industrial use. This breakthrough does not solve climate change on its own, but it is a big step in improvements where CO2 emissions can be recycled into valuable resources. Turning a problem into a solution is the ideal situation for sustainability.